In this video, I want to talk about logs and how we work with those along with exponents. Now, first of all, let me just explain what a log is. A log is a mathematical function that works as an inverse to exponential functions. So essentially, they undo exponents. We've talked about inverses that essentially, like if I knew what the y value was, how would I in general solve for the x? How would I work backwards? A log is the function that helps us work backwards to solve exponents. For example, if I said 5 to the x is 25, you could easily reason through that by just trying numbers and say, well, 5 squared is 25, so x must be equal to 2. But if I said 5 to the x is 50, well, 5 squared is 25, 5 to the third is 125, so it's somewhere between, 2 and 3. It's 2 point something, but we don't know what. Logs help us to solve that. So the first thing we really should know about logs is how to write them and how they relate to exponents. So you'll often see something written like this, and I'm going to use letters so that we can just generalize. A to the x power is equal to b can be written using logs as log base a. So notice that the base of my exponential, this, gets written as what we call the base of the log. So the base number that's being raised, that I'm multiplying by every time, that's also the base of my log. Now, remembering that logs work backwards, they're the inverses, so we have the answer. We say log base a of b equals x, because x is what we're solving for. Now, this works actually both ways. I'm going to put like the double little arrow there. So if I were to say to you, 5 cubed is 125, what would that look like with logs? You'd say, well, log base 5 of 125 is equal to 3. If I were to say 2 to the fourth is 16, with logs, that would be log base 2 of 16 is equal to 4. Let's go the other way. If I were to say log base 3 of 27, now let's not use 27, of 81 equals 4, you could say, well, that means that 3 to the fourth power is 81. Now, I'm going to do kind of a tricky one. Log, I'm going to write 100 equals 2. If no log base is written, if this number right here is just left out, we read that always as base 10. Okay? It's called the common log, and it's basically, we don't even write it because it's the one we use the most. So we would write this using exponents as 10 to the second equals 100. Now, one last one I want to write is natural log. Okay? The natural log of, let's say, e to the fourth equals 4. Now let me explain what the natural log is. The natural log is a log that is basically a shorthand way of writing log base e of, in this case, e to the fourth equals 4. Like that. So e to the fourth equals e to the fourth. So if you see natural log, that really is just log, let me use the right thing here, log base e. Okay? Now, on your calculator, you don't have any of these buttons to solve with. So let me explain how we type this into our calculator. Let me go back to this example. Base 5 of 125 on our calculator can be typed in as log of 125 divided by log 5. And if we type that in, and let me just draw your attention to the fact that there's no base written. That's the one that's on our calculator. So remember, if there's no base written, we read that as 10. Okay? And this will give us 3 as an answer if we type that in. So what this does for us is give us that freedom to solve problems like this one. This first one where I said 5 to the x equals 50. Well, let's rewrite this with logs. Log base 5 of 50 equals x. Well, I can then type this into my calculator doing log of 50 divided by log of 5. Remember, we said it was going to be 2 point something. Let's see what it really is. If we type in log of 50 divided by log of 5, remember we said it was going to be 2 point something? There it is. So what this means is that 5 raised to the, and if I just did second and hit that, putting that answer in without any rounding, 2.43, I get 50. So this is our way of solving those exponential equations, is using logs. So I would make sure to practice this up here and know this is our way of rewriting, because this is our way to easily solve exponential problems. Let's just off to the side do like one more. Let's say I said 4 to the x equals 100. Now, again, let's just think about, 4 squared is 16, 4 to the third is 64, 4 to the fourth is already over 200. So it's going to be 3 point something. But if I rewrite this with logs, I say, okay, log base 4 of 100 equals x. But of course, on my calculator, I type log of 100 divided by log of 4. Log of 100 divided by log of 4, 3.3219. If this video helped you, please like and subscribe for more math help.